Hi guys, today we're going to talk about lesson 4 in unit 2, which deals with the literal equations and coin word problems. So the first thing we're going to talk about is the definition of literal equations. Literal equations are used in mathematics and science. Um, these equations are the formulas that you guys used in science and mathematics since middle school. What literal equations mean is equations that include one or more variables, and each variable represents an unknown quantity. So the first example that we have here is the literal equation that can help us find the area of a triangle. This is a triangle. That's the base of the triangle. And this is the height of the triangle. So this formula is called a literal equation because it has three variables, and each variable represents a specific quantity. A is for the area of the triangle, B is for the base, and H is for the height. So the question is asking us to solve the literal equation for H. This means that we have to isolate H by itself. So again, we're going to start with the formula, and we're going to take a look at this formula, and we will find out that it's going to be a much simpler equation if we try and get rid of 1/2. We know that 1/2 is multiplied by b and h, and to get rid of it, I need to multiply both sides of the equation by 2. Which means I'm going to end up with 2a equals bh. The goal is to have h by itself. That means I need to get rid of b, and b is multiplied by h, which means the inverse operation to get rid of b is to divide by b on both sides. That helps me isolate h by itself, which is going to be equal to 2a over b. And this is the final answer. So the main goal of solving literal equations is to solve the whole equations for one variable. So this variable can be represented by other variables in the equation. Now let's talk about coin problems. We know that 1/4 is $0.25 or 25 cents. We know that 1 dime is $0.1 or 10 cents. We also know that 1 nickel is $0.05 or 5 cents, and 1 penny is $0.01 or 1 cent. We're going to use these values to solve problems that deal with coins. Let's take a look at our first example. Maddie has 11 more nickels than quarters in her purse. How many quarters and nickels does she have if she has 31 coins? I would suggest that you use this following table to be able to deal with coins problems that deals with coins, where you have the types of the coin, the quantity, and the total value as the columns of the table. And then the last row of the table talks about or mentions the totals. So looking at this problem, we have two kind of coins. We have nickels and quarters, and this is exactly what I'm going to put in my table. I know that nickels are 5 cents and quarters are 25 cents. So in this problem, I have the statement 11 more nickels than quarters. This is a very important statement because this statement is going to help me translate the quantity of the coins in this problem. So always represent the later coin mentioned with X, so you'll be able to translate this statement correctly. So in this situation, since quarters is mentioned after the word nickel, I'm going to start with quarters, and I'm going to assume that the number of quarters is X. Now, it says in the problem 11 more nickels than quarters. So that means if I have X number of quarters, I have X plus 11 number of nickels. And this is the hardest part of setting up the equation, is to identify exactly the quantities and the total value of the coins in the problem. After that, in the problem, it says how many quarters and nickels does she have if she has 31 coins. And 31 coins in this situation, it's just the quantity, the total number of coins. That's why 31 is going to be in the total for the quantity. Now that we have all the information that we need in the table, we don't have to find the total value of each coin, just because of the fact that we don't have a mention of the total value of the money that we have in the problem. So to set up the equation, I know that the total quantity of the coins is 31. That means I need to add the number of nickels to the number of quarters, because the number of nickels plus the number of quarters is 31. That means I'm going to end up with 11 plus X plus 11 plus X equals 31. Taking the parentheses away, because we have addition, we end up with X plus 11 plus X equals 31. As you notice here, we have like terms, X and X. That means I'm going to put these two like terms together into 2x plus 11 equals 31. To solve this two-step equation, all I have to do is to take away 11 from both sides. Going to end up with 2x equals 20. Divide by both sides by 2, and then x is going to be equal to 10. That means that we have 10 quarters, because that's the number of quarters that we have, and then the number of nickels is going to be 10 plus 11, which is going to be a 21. So the final answer for this problem is going to be 10 quarters and 21 nickels. Now let's take a look at the same problem, but this time we have the total value of the money. Maddie has 11 more nickels than quarters in her purse. How many coins does she have if the total value of her coins is $2.65? So in this case, I'm going to use the table again. I know that I have nickels and I have quarters. I know that the quantity of the quarters is X. Nickels is X plus 11. The only difference between this problem and the previous problem is that we have the total value of the money. We don't have the total quantity or number of coins that we have. So in this case, $265 is 265 cents. So I'm going to put this number in the total value of the money, which is right here. Now, since the total value is in the total value is in the total value column, I'm going to have to find the total value of the nickels, which is, and the total value of the quarters. The total value of the quarters is going to be 25 cents times X number of quarters, and the total value of the nickels is going to be 5 times the number of nickels, which is X plus 11. So all I did here is I multiplied 5 by X plus 11, and I multiplied 25 by X. This will give me the total value of the nickels and the total value of the quarters. And when we add these total values, we'll end up with 265 cents. Now, this is an equation that we need to solve for x. That means I need to use the distributive property. 5 times x equals 5x, 5 times 11 equals 55, plus 25x equals 265. I have like terms. I have 5x and 5x, 25x. I need to put these two like terms together. I'm going to end up with 30x plus 55 equals 265. This is a two-step equation, which means I need to take away 55 from both sides, end up with 30x equals 210, divide both sides by 30, and x is going to be 7. Now 7 is the total quantity of quarters, which is 7 quarters, and the number of nickels is 7 plus 11, which is equal to 18. So the final answer for this problem is going to be 7 quarter and 18 nickels. So the main thing when solving word problems that deal with coins is, first of all, using the table, because the table is going to help you so much in setting up the equation correctly, and finding out if you have the number of coins or the quantity of the coins, or if you have the total value of the coins.